So let's discuss a topic from quantum mechanics. So it is nothing but spin of Dirac particle in central potential. So what would be the spin of a Dirac particle in central potential, which can also be said as existence of spin angular momentum. So how we came to know about the existence of spin angular momentum. So these topics you are going to see, they are is one and the same. So let's discuss. So spin angular momentum existence or existence of electron spin. The Dirac's Hamiltonian in stationary central field represented by the potential V of R is. So here the particle is in this central field, stationary central field. It is not a free particle. If it were a free particle, then V of R is potential is 0. But here it is said that the particle is in central potential field. So it has got some potential, that is V of R. So for this particle, Dirac's Hamiltonian equation is H is equals to C into alpha dot P plus beta MC square plus V of R. So this is the equation of Hamiltonian. C is the velocity of light, alpha, beta are the Dirac's matrices, P momentum, and V of R is the potential. Now, for a particle under the influence of central force, torque is 0. Therefore, angular momentum of the particle is conserved. So, in central force, the torque is 0. So, how is this possible? Means we know that gravitational force is also a central potential. Suppose here sun is there, here some planet is moving. So here we know that torque is nothing but tau is R cross F. R cross F. So what happens now? Position vector is in this direction, that is it connects planet and the sun. If we consider in central potential, central force, actually gravitational force is a central force. So actually the path would be somewhat elliptic, of course. Planets orbits would be elliptic. So if we think so, it would not perfectly circular, it would be elliptic one. So if the planet is here, so for example, if we consider, so this is the position vector, and if we want to know about the this is the direction of position vector which connects sun and the planet. Next this is direction of force. Here the direction of force is radially outwards or radially inwards, like that. So the central forces would be acting radially outwards or inwards. So the sun's gravitational pull would pull the planet towards it, but because of the movement of the planets, centrifugal force develops, so both of them get balanced. So like that we know. So here if we see the direction of force, so the direction of force and the direction of position vector are one and the same. So this is force and that is position vector, that means they both are parallel. So based on this formula, R cross F is nothing but RF sin theta into n cap, that is the direction, final direction we would get. So here if we see the angle between R and F is theta, that is equal to 0. So sin 0 0. So finally what happens? Torque is equals to 0, because they both of them are parallel, or it might be anti-parallel like that. So hence here it is mentioned that in central force the torque is 0. So for the central forces, torque is 0 because the position vector and the force which acts radially in radial direction, both of them are parallel. So that is the explanation for this. So therefore the angular momentum of the particle is conserved. Now here it is said that angular momentum of the particle is conserved. You know that torque is, another formula for torque is dl by dt. Just like the formula for the force, F is equals to dp by dt. So as the torque is 0, that means dl by dt is 0. So then it means L is a constant. So that is nothing but it is conserved. Hence the angular momentum of the particle is conserved based on this formula. Now finally, now next thing is classically, the orbital angular momentum r cross p is a constant of motion in a central field. So, this angular momentum is constant, it is conserved in central field. We shall now see whether this is so in Dirac's theory or not. So, in central field, we already know that angular momentum is conserved. Now, we need to see from the Dirac's point of view, in Dirac's, according to Dirac's theory, whether it is constant or not. So in quantum mechanics, any operator that commutes with Hamiltonian is the constant of motion. So we know that the commutator relations AB, that is commutation between A and B, like that. If any quantity, so if AB minus BA is equals to 0, that is nothing but they commute with each other. Commutator A and B commute with each other. So in the similar fashion, so if any commutator commutes with this Hamiltonian operator, we can say that it is a constant of motion. So let us examine this x component of the momentum. So now we need to examine x component of the momentum, that is angular momentum. So here it is given commutation between Lx and h. If we find commutation between Lx and h is equal to 0, then we can, and Ly in the similar fashion, if we can say Ly and Lz also commutes, then we can say in overall angular momentum vector operator commutes with Hamiltonian. So we need to see whether it commutes or not. Now we are going to examine that. So Lx into h, that is nothing but IH cut dou L by IH cut dlx by dt. So this IH cut dlx by dt could be written as this form, that is the commutation between Lx and h. So in such a manner also we could write this. Then based on the commutator relations, if we solve this commutator relation, we would get this. So in the place of h, if we take IH cut d by dt, so like that if we substitute and if we apply this formula for upon the wave function xi, then we would get this formula. So here, so Lx is as usual, and h is nothing but c into alpha dot p plus beta mc square plus v of r, as we have seen here. So based on this, and now we know that alpha is nothing but alpha x I cap plus alpha y j cap plus alpha z k cap, and p is nothing but px I cap plus py j cap plus pz k cap. So if we do dot product between them, so we would get this term c into alpha dot p and plus beta mc square plus v of r as usual. Now we need to split up this. So in commutator relation, we are having the formula this commutation between a comma b plus c. So then we would do distribution, commutator of ab plus commutator of bc, like that. So here you can see commutation of ab, commutation of ac. So here also we need to just split up this. So first of all, commutation of lx and c into alpha x px. So this is, we would get this term. And next, commutation between Lx and alpha x py. So we would get this term. And next Lx and alpha z pz, we would get this term. And next another terms are remaining, commutation between Lx and beta mc square, so this term. And next commutation between Lx and v of r, so we would get this term. So based on this formula we are getting this. Now but Lx commutes with every quantity in X except for Py Pz. So here Lx is going to commute with each and every quantity except Py and Pz. So that one they are saying. So here you can see Lx alpha x px beta mc square commuting with v of r, all of them. It is going to commute with all of these quantities. So it would commute just like AB minus BA formula if you apply. So this is a kind of constant like, and this is also a kind of constant like, and here Lx we will get dou by dou z terms, but here px is there. So based on this everything, dou by dou x everything, so finally we would get they all commute with each other. And next thing is now we need to see what would after it gets here in total 5 terms are there, 1 2 3 4 5. So out of these 5 terms this term are gone, because they are going to Lx is going to commute with them, so that is 0. So finally these 2 terms would remain, so those are written here. So I cut dlx by dt is nothing but, so actually it is x here. So here it is x, Lx c alpha y py plus Lx c alpha z pz. So this is the term which is going to remain. So now what we need to do is, but Lx commutation of Lx c alpha y py is equals to, they have given this. So here if we see, we need to apply another formula here, that is this formula, commutation of a comma kb, where k is a constant, so it could be taken out. So here it has been taken out, and separately we are going to commute a and b operators. So here also the same thing. So here c alpha y is a kind of constant like, so we are taking it outside, and we are doing commutation between Lx and Py, and we know that Lx component is this ypz minus zpi. So based on the formula of L is equals to r cross p, so if we do dot product between r and p, we would get this Lx component has this ypz minus zpy py. So next, so c alpha y here what they have done is distribution. So first of all, here we need to split up the terms. So ypz py, commutation between ypz py, and next commutation between minus zpy py. So that is the thing we have done here. So that one we have did in this step. And next step, it is of the form, this term and this term are of the form, this form, commutation of ab comma c is equals to a into, so in this way we need to split up. Here you can see formula. So first of all we need to keep a on the left side, because here it is standing on left side, and we carry on commutation between b and c, so that is this term. And next next we need to keep b aside onto the right side, because it is standing on the right side, and left out term is ac, so we are doing commutation with ac, and b is kept on the right side. So here the commutators, we can't say ab is equals to ba, just like matrices, product between a and b is not equal to b and a, so like that. Here because of that we need to keep, if the operator is on the left, we keep it left, if it is on right, we keep it right. So by applying this formula we would get this term. So for this, if we apply this formula, so ypz, keeping pz aside onto the right, and here keeping y onto the left and pz py. So that is the thing. And next is if we see this, so we would get two terms, that is zpy py, again plus zpy into py. So as here py we already know that computation of a comma a is nothing but 0, so this one would become 0. This one is going to be 0. And here if we see, we know that computation of xpx is equals to I cut. So based on that, and computation between z and y is going to be 0, because we know that py is nothing but minus I cut dou by dou y. If we do partial differentiation to on z, it would be definitely 0. So zpy, xpy, so all of them would be 0. So finally this entire thing would become 0. So that one we can see here. So here what we have got is only because of this term. So here you can see only because of this got splitted up into these two terms, and this is 0 based on the explanation given now. So next we know that ypy is nothing but I cut. So ypy, xpx, zpz commutation, so all of them would give I cut. So that I cut. And here pz py, we know that pz is nothing but dou by dou x minus I cut dou by dou x, and py is nothing but dou by dou y. So it is just like what we will get is dou by dou, again dou by ab minus ba, no? So dou by dou y dou by dou x operating on wave function. So this is nothing but 0 partial derivation, whether we are operating dou by dou y first and then dou by dou x, or else dou by dou x first then dou by dou y, because this is a partial differentiation, they would be the same. So on subtracting them we would get 0. So hence we are get this one, again this term would become 0. So that 0 we have mentioned here. So this is only because of this. And next, so hence finally commutation of lx c alpha y py, so that is the thing we have taken, lx c alpha y py is equals to c into alpha y I cut pz. Now in the similar fashion another thing is there, alpha z pz commutation between lx and c alpha z pz, so that would be minus I cut py. So based on the cyclic order, so here we need to go in cyclic order, that is here x y is there, okay, x y z, so x to y, y to z, z to x, that would be positive. So here lx py is there, x y, so we are getting positive 1, and pz, it is pz. And here lx pz is there, that means actually the order has to be zx from here to here, but it is going from x to z, so we are getting negative 1, and other than x and z, y is the thing. So based on this, in a similar fashion we can say we would get this term. So finally, therefore equation 5 yields, so equation 5 in, so this equation 4 and equation 5 put together is nothing but I cut dlx by dt. So we have found this term. Now we need to substitute them, that's it. So that is another c alpha y I cut pz and c alpha z minus I cut py. So if we take minus I cut as common, so from here what would remain is, from here alpha z py, so alpha z py from here has minus not there, so minus into minus, so here minus alpha z pz would remain. So finally we are getting this. So and this is not equal to 0. So finally we can say that dlx by dt is not equals to 0. So after this cancelling I cut, then also this is not going to be equal to 0. So dlx by dt is not equal to 0, then lx is not a constant of motion. So that is the conclusion. So in Dirac's field, uh, it is in the central field, the Dirac's particle is not having this constant orbital angular momentum. So hence in Dirac's theory, the x component of orbital angular momentum of an electron moving in central electrostatic field. So here the field is electrostatic field. Electrostatic field is also a central force field. So the electron moving in a central electrostatic force field is not a constant of motion. So that is the conclusion. So here orbital angular momentum of the electron moving in this field is not a constant. But so in other words, orbital angular momentum does not commute with h. So if it were a constant of motion, then it would have commuted with the Hamiltonian easily. So however, we expect on physical grounds that it is possible to define total angular momentum, that is a constant in the central force of field force. So here the point is, so uh, here actually the quantity, some quantity has to be a constant of motion. So by differentiating that quantity, we must get 0. So by differentiating that quantity, we should get 0, some quantity. So but we are not getting 0. uh, so what could be done is, so if we are not getting a equals to 0, actually we want here something, some quantity must be equal to 0, just like dl by dt must be equal to 0. So we are not getting that. So what can be done is, if we add something to this quantity such a manner, so actually it was not equal to 0, so if we add something to this, it would become 0. Just like here the quantity a has to come to be 0, but we are getting it to be 5. So in order to make this quantity into 0, what we can do, a minus 5, we can do a minus 5, then we would get 0. So we are adding this extra minus 5 so that it would become 0 finally. So based on that, based on this is the technique used here. So by this we came to know that, yeah, if we are not getting orbital angular momentum 0, then if we could add up some another angular momentum to this angular momentum in such a way that it turns out to be 0, its its derivative with respect to time turns out to be 0. So like that they have taught. So then came a some angular, not only angular momentum added with some quantity. So the angular momentum has been added with some quantity, so that in overall we could get the differentiation of that quantity 0. So then came total angular momentum. So that is a constant in a central field of force. This means that we must find another operator such that the commutator of its x component with h is exactly equal and opposite of right hand side of 5. So right hand side of 5 is this, right hand side of you can say equation 6. So the quantity differentiation of another quantity must be exactly equal to this, must be opposite in sign. So now only we have said, so 5 is not equal to 0. In order to make it to be 0, we need to add minus 5, then it would easily turn out to be 0. So that is the same thing here we are doing. So this quantity we have got this term, so that quantity which we are adding, so that's differentiation must be equal to this but must be opposite in sign, so that they both added up to get 0. So that is the key point here. So that sum of this operator and L is then a constant of motion. So then we would get a constant of motion. L added with something, differentiation of L added with something with respect to time, it would become 0. Can be interpreted as the, and that entire quantity is nothing but total angular momentum. So the angular momentum is of two types. Then we came to know about uh, orbital angular momentum and spin angular momentum. They both put together would give total angular momentum, and that's it is a constant of time in central force field. So it is not difficult to see that the desired operator is a multiple of sigma defined by, so the operator which we needed here is a multiple of sigma. So sigma is nothing but, here it is mentioned, sigma dash, sigma 0, sigma 0, sorry, sigma 0 0 sigma. So this is nothing but sigma dash, so that has to be of this form. So let us take x component of sigma dash. So if we take x component of sigma dash and if we differentiate, so that is, this is the quantity we need to add up to Lx, so that Lx plus sigma x dash differentiation with respect to time is 0. So here I h squared d sigma dash by dt, so that is nothing but sigma x dash h comma h. So now what we need to do is we need to find out this value. So here I h squared d sigma dash by dt, that is nothing but sigma x dash comma h. So this is the Hamiltonian, c into alpha dot p plus beta mc square plus v of r. So alpha dot p is nothing but this after the dot product. So but sigma x dash commutes with every quantity in above equation except alphas y pz. So here sigma x dash is going to commute with alpha x and alpha z pz. Sorry, actually it commutes with every quantity above equation except, so it is going to commute with all the other quantities except these two quantities. It is not going to commute with these two quantities, but with remaining all quantities it is going to commute. So beta mc square v of r, they are just like a kind of constant, like, so so it would definitely commute. So we need to see whether it commutes or not. So here the proof is given. So sigma x dash beta minus beta sigma x dash. So this is nothing but commutator relation between sigma x dash and beta. So this is sigma x and beta, we know that I 0 0 minus I. In compressed form it is 1 0 0 minus 1. So AB minus BA. So now if we do matrix multiplication, so sigma x into 1 sigma x and plus 0 into 0, that is finally we would get sigma x. And next sigma x into 0 is 0. Next plus 0 into minus 1 is again 0. So 0 plus 0 is nothing but this 0. And next 0 into 1 is 0 plus sigma x into 0 is 0. So that is nothing but 0 plus 0. So again we are getting 0. Next 0 into 0 is 0 plus sigma x into minus 1 is minus sigma x. So in similar fashion for this also, if we do matrix multiplication, we are going to get this. So here you can see sigma x minus sigma x, 0 0 minus 0 0 minus 0 0 minus sigma x minus of minus sigma x, that is plus sigma x. So all the corresponding elements are 0. So this is nothing but a null matrix. So hence they are commuting with each other, sigma x dash and beta. Next we need to see with alpha x. So this is sigma x. So no need to here, don't confuse between these two matrices. So sigma x, here we are having diagonal terms. Principal diagonal terms are non-zero. But in alpha x, diagonal terms are 0 because trace of all the elements is nothing but 0 based on property of Dirac's matrices. So that one we need not be confused. So sigma x dash alpha x sigma x dash. So if we see now matrix multiplication, sigma x into 0 0 plus 0 into sigma x 0. So finally we would have 0. And next, sigma x into sigma x, that is sigma x square plus 0 into 0, 0. So finally we would have sigma x square. Next, 0 into 0, 0 plus sigma x into sigma x square. And next, 0 into sigma x, 0, and sigma x into 0, 0. So finally we would have 0. So these are the things. So in similar manner, here also if we do the matrix multiplication, we are going to get this. So if here we see on subtracting the corresponding elements, 0 minus 0, 0, sigma x square minus sigma x square, 0, sigma x square, 0, 0. So finally we would get here also null matrix. That means they both commute with each other. Hence equation 7 gives. Hence finally equation 7 is going to give. So now we have seen, so with b times square v of r, it is going to commute, and alpha x it is going to commute. So these are the two things remaining. So alpha y py c into alpha z pz. So now we need to see what happens with this. So now here again we need to split up. It is just like a plus b, c a plus b. So ca plus cb. So this, and next, now we need to do commutation between sigma x dash and alpha y. So here alpha y is there, so that alpha y. So now we need to see what happens if we do commutation with alpha y. So actually here we need to apply that c is a constant, it could be taken out, and py alpha y is there. So after getting the splitting based on commutation of a b comma c, a of b comma c plus a comma c into b, that commutator formula. So what would remain is this would remain commutation of alpha sigma x dash alpha y multiplied with c and py, and commutation with sigma x dash and py would get turn out to be 0. So now if we see commutation of alpha x dash sigma x dash and alpha y, so sigma x dash comma alpha y, that is nothing but sigma x dash into alpha y minus alpha y into sigma x dash. So now if we do as we have done previously, so here principal diagonal terms, here these terms are non-zero. So if we do matrix multiplication as we have done before, so we would get these terms. So sigma x into 0, 0, 0 into sigma y, both turn out to be 0. Next, sigma x into sigma y and plus 0 into 0. So sigma x sigma y. So next, 0 into 0 and sigma x into sigma y. So sigma x sigma y. Next 0 into sigma y, sigma x into 0, 0. So finally here also if we do matrix multiplication we would get this. So actually what we would get is if you see 0 into sigma x 0, sigma y into 0, so that is 0. But next thing is very important, 0 into 0, 0, sigma y into sigma x. So we would get sigma y into sigma x. But here it is written minus sigma x into sigma y. So that is because of the Pauli's matrices anti-commute. So sigma x sigma y plus sigma x equals to 0. So sigma x could be written as minus sigma x sigma y. So that's why here we have written minus sigma x sigma y, only to see the calculation, make the calculation easier. So here also like that. So now what we need to do is we need to, here they both would add up, minus of minus plus. So 2 sigma x sigma y we would get 2 sigma x sigma y. So we know that sigma x sigma y is I sigma z, so that one they have written here, I sigma z, here also I sigma z, so they both would add up to give 2I sigma z. So 2I sigma z, here also 2I sigma z. So there we can take 2I common, because 2I 0 into 2I is again 0 only. So if we take 2I common, 0 sigma z 0 would be remaining, that is nothing but alpha z. So 2 0 sigma z 0, because we are taking 2I as common after this solvation. So finally we will get 2I alpha z. So in the similar manner it is given here, commutation between alpha x dash, sorry, sigma x dash and alpha z is minus 2I alpha y. So here you can see x y, so it is in cyclic order, but here x z, instead of being zx it is xz, so minus we are getting. So same as this, here plus 2I, here minus 2I, here alpha z alpha y. So now hence equation 8 gives. So finally equation 8 would give us, this is equation 8. So now only we have found this one. In the similar fashion this also we have done. After applying commutator relations, finally this this term and that term would remain, and its commutation is nothing but this. So here we have substituted 2I alpha z py 2I minus 2I alpha y. So here as c py is taken out, sigma x dash alpha y would remain. So based on that, now so here we can take 2ic as common. So here 2ic and here also 2ic is there. If we take common, what would remain here is alpha z py minus alpha y pz. So that is the thing here you can see. Now what they are doing is multiplying both sides by half h cut. So on both sides if we multiply with half h cut, here already h cut is there. So if we keep it aside, I h cut, here d by dt is also there. If you keep that aside, so as I h cut is a constant, so we know that d by dt of some constant into function is nothing but k into d by dt of that function. So d by dt we can take that I h cut inside, sorry, I h cut by 2 inside. So that's why here we have taken I h cut d by dt is nothing but this, and inside we have taken half h cut sigma x dash. And here if we see, if we multiply here with half h cut this side, on the right hand side half 2 would get cancelled, I h cut c would be remaining. So alpha z py minus alpha y pz. Now next thing is adding 6 and 10 we would get. So now what we have to do is 6 is nothing but d I h cut dl by dt. So here you can see sixth equation. So is it, so I h cut dlx by dt. So we have got that one to be this one. So here this is a quite exact opposite of that one we can see. So there minus I h cut we had, here we are having plus I h cut. So that is the thing they are saying. So if we add up them, as they are equal and exactly opposite to each other, so that is nothing but 0. So finally we are getting this is turned out to be 0. And here d by dt is so finally what we can say, we can send this I h cut to that side. So finally if we take d by dt out, what would remain here, lx would be remaining, here half h cut sigma x dash would be remaining. This half is also very important here. So finally d by dt of lx into half h cut sigma x dash is equals to 0. So instead of getting dlx by dt equals to 0, we are getting here dlx by dt is not equal to 0, but dlx added with this particular term, it has been added with this extra term, and its differentiation made it to be 0. So this extra term, so this is a constant, overall if you see. Hence the quantity J is equals to, that is total angular momentum, is nothing but L plus half h cut sigma dash, that is nothing but L plus S. So hence S is nothing but half h cut sigma dash, which commutes with h. Therefore we can take it as total angular momentum. So here J is nothing but the total angular momentum, and here S dash is S bar is nothing but spin angular momentum of the electron. So finally we have confirmed that electron is not only having orbital angular momentum, it is also having spin angular momentum. Hence Dirac's theory automatically endows the electron with properties that account for the phenomena previously ascribed to a hypothetical spinning motion of the electron. So finally it has proved that spinning motion of the electron, in addition to orbital motion, spinning motion of the electron also exists, just like the planets. So planets would be revolving around the stars, their own stars, just like the planets in our solar system, they will be revolving around this sun. So it gives rise them the orbital angular momentum. In addition to that, they would rotate about themselves, so rotate about their axis. So like that, it's a angular momentum caused because rotation of the earth about its own axis. So they both this angular momentum would get added up. So here also, yeah, in addition, not only orbital motion of the electron, so within electron it is spinning, that also must be considered. So both of these put together, we are getting this Dirac's particle actually. So moving charges produces magnetic field. So if the electron spins, rotates about itself, then also it is a kind of rotation. So because of that, it would have act as a tiny magnet. In addition to that, it is moving around the nucleus or wherever field it is present. So it is making a rotation about it, revolution about it. So because of that motion, so it is in because of that motion, it is going to get orbital angular momentum, or and orbital magnetic moment also. Because of that also, it is going to act like a magnet. So hence we have got spin of the Dirac's particle, that is half h cut sigma dash. So this is the topic. So thank you.